Hi, everyone. Thank you for joining this session where we're going to talk about how we are building an open source government application platform in the cloud. We are 3 team members of the team that is building the Altinn platform for the Norwegian Digitalization Agency. The team consists of members both from the agency itself and consultants from different companies. My name is Rune T. Larsen and I work for Accenture Technology. And I've been doing that since 2005. I've been working on the Altinn Platform since 2008 and I was part of the team that originally built the second generation of Altinn. I'm a developer and technical architect and I do most of my coding in .NET.
Hi everyone, my name is Nina Kylstad. I also work at Accenture Technology and I've been working there for the past 6 years. For the past 5 years I've also been working on the Altinn Platform. I am a developer and technical architect, and I like to think of myself as a full-stack developer, but I do work mostly front-end these days. Outside of work, I have a 1-year-old who keeps me busy most of the time. When I do have some spare time, I'd like to read, and I've also dusted off my sewing machine in these times where we're staying so much at home.
Hi guys. My name is Stephanie Buadu. I've been with Avanade and the Altinn team since 2018. On this project, I've focused mostly on the backend part of our solution and also our integrations with Altinn too. In my spare time, I quite like knitting, and that's a great hobby to combine with Netflix, so I do quite a bit of that as well.
So in this presentation, we're going to talk about what Altinn is, give you a little introduction for you guys who doesn't know that. We're going to talk about the project, Altinn project, how that started and our technical principles. We are building a new platform. We're going to go into details about the new platform, the components and the solution we are creating. And then we are going through the cloud architecture and components we are using as part of the solutions. Give you the current status and what we will do working on next. And at the end, we open up for questions. So please ask questions on Slack if you have any. So what is Altinn? Imagine you work for a government agency that needs to get data from the citizens of Norway. Maybe you want them to report their COVID-19 symptoms. And maybe you want a digital service online that can receive that data. Then Altinn is the platform for you. Altinn is an internet portal for dialogue between the citizens, the businesses and the agencies of Norway. It's also a technical platform where the agencies can build and host the digital services. You can say that Altinn was one of the first platform as a service providers because it already started back in 2002 when 3 agencies joined forces to build a common platform for reporting to the government. And in 2003, the first generation was launched. In 2010, the second generation went live. And during those years, more than 50 agencies had joined the platform, including the armed forces, the police, health, and many more, covering most of the government sectors of Norway. There are now more than 1,000 digital services available through the platform. And that includes everything from naming your firstborn to report on aircraft incidents. Almost all businesses in Norway uses Altinn every year. And as this diagram shows, almost everyone from 13 to 110 uses Altinn every year. In Altinn, everyone has their own inbox where they find their communication with the government. You also have a service catalog where you can find your digital service and what you need. Having this common platform is quite unique and is regarded as one of the reasons that Norway is a leader in digital government. One other good functionality is that every functionality is available through APIs, so there are lots of software vendors have implemented integration with Altinn, so you, as an example, can submit your tax report directly from your financial system. Gartner regards Altinn as one of the top 5 government technical platforms in the world. So, back again to the agency and the need for having data from the government. What I'm just said, maybe you think that Altinn 2 is the perfect platform, but there are some limitations. we base the current platform on physical hardware. So even if our traffic varies from 100,000 a day to 2.5 million a day, we are scaled the same all year long. And as an agency today, you will need to make a digital service that is well supported on mobile and on desktop. But we are using InfoPath, and it's very limiting in what you can do with that. In addition, there is a limitation on what kind of process flow you can support for end users. It's quite time-consuming to do testing, because every time you do a little change, you need to deploy it to the test environment. And version control is done through SharePoint, so it's very difficult to understand what kind of changes you or others had done previous on your digital service. And when you're done testing, you're ready to go in production. In today's platform, you need to get help of a technician to deploy it. And those are some of the limitations we are started building on the next generation of Altinn. So this project started already back in 2016. And we had at that time looked into what kind of product could replace InfoPath. But we realized maybe we should try to build something from ourselves, from scratch. So we did a small proof of concept at that time, just verify, are we able to build a platform using ASP.NET Core? And we kind of, yeah, it's possible. And in 2018, we were ready to do a full-fledged proof of concept. We wanted to build a new platform using .NET Core. We want to use React as front-end. We want to use Docker and Kubernetes. And in the spring of 2018, we started to verify, are we able to do this? And during the summer of 2018, we were saying, okay, we were able to prove our main concept, that is, we are going to build a UI designer using React. So we then finalized the concept and getting ready to start a minimal viable project. And that is what we are presenting to you guys today. So what is our concept on the new platform? So we will let the developers working for the agencies be able to develop by themselves or as a group digital services, deploy it to production as containers to a public cloud infrastructure. And all that without you needing to know programming or need to know anything about cloud infrastructure. Pretty cool. So to do this new platform, we define some architecture principles. And I'm just going to mention the 5 most important ones. So we want to be open source. We want others to use our platform and components if they want. Other agencies want to use it internally or maybe a different country. And we also want contribution from the agency that needs some features to the platform. So all our code is available on GitHub. All our issues are available on GitHub. And we only use tools and frameworks that are open source. The second principle is that we really want the platform to be loved. So we build with tools that the developers like. So we have chosen the most loved web framework according to Stack Overflow, React. We are using the most loved backend framework, that is ASP.NET Core. And we are using 3 most loved platforms since we are using Linux containers based on Docker. And everything is built around Visual Studio Code. That is the most loved development environment. We truly love working with our platform, and we believe that others will too. These are some of the tools we have been using in our platform. The third principle for a new platform is we're going to build everything as microservices. We want to be able to scale independently the different components. We want to be able to deploy them. We want to be able to have teams responsible for different components. So every component is deployed as a microservice, and all the digital services are created and deployed as a microservice. The fourth principle is also very important for us, because we are going to end up with a big infrastructure in the cloud. And we are not able to run that by ourselves if we're going to manage it as a team. So we favor using managed services available in Azure. As an example, Azure Kubernetes service. Stephanie will tell you more about that later. And the last one, application owners will be isolated from each other. You don't want an application owner to be able to affect the service for others or be able to access data for others. So we have isolated infrastructure for every application owner, and we also have isolated and separate data store for every application owner. Then Nina is going to tell you more about the solution we are building.
Thank you, Rune. Oops. All right. So we had our overall concept, and we had our architecture principles, and we had the proof of concept ready. And based on this, we started building our solutions. Altinn 3 is made up of 3 solutions that work together. First, we have the Altinn Studio solution, and this is our design time solution to create, develop, and deploy applications, or apps, as we call them. We have the Altinn Apps solution. This is the collection of all of the running apps and the Kubernetes clusters on which they run. Finally, we have the Altinn Platform solution, which provides the common backend functionality for the apps. So let's look now at how these 3 solutions work together to support the next generation of digital services for the people of Norway. So let's go back to this scenario of a government agency that wants to collect some data and they want to create a digital service to do this. And we'll see how we can solve this by creating an app using the Altinn 3 solutions. Now, these are some of the key features that we want to support, and these are also some pain points from the existing platform that we would like to improve on. So, what is an app in this context? Well, an app is a digital service in the form of a standalone application. And this application exposes some APIs, it has some sort of graphical user interface, and it runs in a Docker container. So to support this, we have created an app template. This is the starting point for all of the apps. The app template is built is an .NET Core MVC application, completely standard, and then we have extended it with some supporting libraries. These are projects that we publish as NuGet packages. Now, NuGet is .NET's package manager. And these supporting libraries contain things like the standard APIs that the apps should expose, as well as integration with the Altinn Platform. We've also added placeholders for custom logic and a set of configuration files that the app developers can use to configure the apps. The app also refers to a front end. This is a React application that is loaded from a content delivery network at runtime. All of the apps use the same front end by default. And the front end can then be configured to work with the specific apps. The front end integrates with the app itself via the APIs that the app exposes. So let's look a little bit at how an app developer could actually customize the app. As I mentioned, one of the ways to do this is through a set of configuration files. One of the most important configurations that we set up is the process. The process defines the set of tasks that the end user that actually uses the app must go through. So, for example, if we look at, think back at our scenario of a government agency that wants to collect data. So the end user might have to, for example, fill in a form. This would be a data type task. They might then have to confirm that their data is correct. So this would be a confirmation task. Finally, they might need to wait for some response from the agency that they are submitting their data to. And this would be the feedback type task. So these are the 3 task types that we support. And they can be combined in any way to create a process. Now, defining the process is done through the process configuration file. And when we set up our configuration files, we tried, where possible, to use existing standards for the format. For the process, we use the BPMN 2.0 standard. This is an XML notation for defining processes. We have also used the XACML standard for our authorization policies, and this is an XML standard for defining access control. Now, authorization policies can be applied to the entire app as a whole or to specific process tasks. So that was a little bit about setting up the app using the configuration files. Now, the app developers can, of course, also customize the apps through code. As I mentioned, we set up some placeholders for custom logic. Now, this is for things like validation, calculation, or pre-filling of data. But this is really just the beginning. App developers can really do anything they want as long as they can put it into code. For example, they could fetch data from the Altinn Platform or from external sources. They could create and expose APIs, and the list goes on. And really, as I said, if it can be coded, it can be done. Now, let's take this one step further. I said that the apps all use the same front end by default, and then that front end can be configured. Well, imagine that this doesn't cut it. You can't configure the standard front end to do what you want it to do. All right, replace it with something different. Since we just refer to the app front end from the app, you can just refer to something else and load it at runtime. Or drop the front end entirely and have your end users go directly to the app via the APIs. And if we go even further now, nothing is really stopping you from doing the same thing with the app template itself. You could, if it doesn't work for you, you could replace it with something different. Maybe even a Java application. Now, personally, I would not choose to replace our beautiful, amazing .NET app template with a Java application. But joking aside, if the standard template doesn't do it for you, then of course it is possible to replace it with something else. And we see that in the future we might actually have a set of app templates using different technologies that you can choose from when you are creating an app. All right, so let's go back now and assume that you want to keep the app template and front end as is, and then just work on configuring it. Now, as we've said before, we want the UIs to be modern. They want them to work on both desktop and mobile. And one of the ways to configure the UI is by creating a form for collecting data. So, as Rune mentioned, we decided to build our own tool instead of using existing tools to do this. So we built a drag-and-drop forms editor using React. And this forms editor has a library of available components that can be dragged into the form layout and then configured. Now, currently, we only support very simple forms with a single column layout, and we do aim to expand on this. When an app developer works on developing, on configuring a form like this, the actual form configuration and the definition of the form is stored in a JSON layout file. So this is our form layout file, and it defines how the form should look. At runtime, the app front end then parses this layout file and renders the form. Now, this configuration is for the data type tasks, so forms are for collecting data. But we do have the possibility to configure views for the other task types as well. So that would be confirmation and feedback. We have views for these, and the app owners can then configure the content that will be shown in these views. Now, so far I've talked about the apps, but how do we actually develop apps into complete digital services? Well, this is done in the Altinn Studio solution. Altinn Studio is made up of 3 parts. We have the designer application. This is the graphical user interface that app developers use to create and develop their apps. This is what it looks like. In the designer application, we have things like the forms builder that I just showed you. We have an editor for setting up texts, for language support. We have some support for simple code editing using an embedded code editor, and of course, deploy. Now, the designer application integrates with the repository application. This is where all of the apps in Altinn Studio are stored. The repository application is built on Github. This is an open source code hosting solution that uses Git. And it looks like this, a little bit like GitHub. Now, each app in Altinn Studio is stored in a Git repository. And when an app developer works on an app in the Altinn Studio solution, they are working on a clone of the central app repository. And when they're done with their changes, they can push their changes to the app repository. Now, this makes it easy for multiple developers to work on the same app at the same time, and all of the files are version controlled, just like normal source code. We have set up a load balancer to route between the repository application and the designer application based on the URL that comes in. Now, building applications through a graphical user interface, drag and drop, it's cool. Unfortunately, not all of the functionality of the apps is supported to be configured through a graphical user interface in Altinn Studio. In addition, some developers might actually like to use their own tools, especially when it comes to writing code. So we support local development, where app developers can use their favorite tools to work on the apps. So once an app is created, it can be cloned to your local computer where you can work on it. Once you're done, you can push it back up to the app repository for deploy. Now, one very important aspect of developing an app, which I haven't talked about yet, is testing. Apps need to be tested. And the apps need the Altinn Platform solution to actually run. So one possibility is to deploy the app to a test environment where the Altinn Platform solution is running. However, if you are just testing while you are developing and testing incremental changes, this could be very time-consuming. So in order to support local testing, we have created a platform mock. Now, this can be downloaded and run in parallel with the apps in order to actually test the apps locally on the fly while developing. This platform mock is also used a lot by the development team when we're developing new features for the apps. All right, let's look at deploy. Apps are deployed from the Altinn Studio solution to a Kubernetes cluster in the Altinn Apps solution. Now, as Rune mentioned, each app owner or government agency has their own Kubernetes cluster to which they deploy their apps. And this is true for both test environments and production. This means that the apps of one agency do not affect the apps of another agency. And this is what allows us to provide self-service deploys all the way to production. Now, deploy is a two-step process. First, we need to actually build the application, and this builds a Docker image for the app and then pushes it to an Azure container registry. And this is done via an Azure DevOps pipeline, which you can see an example of here. Once the build is done, we can deploy the app to the environment that we choose. And this fetches that Docker image and deploys it to the specified environment. Again, done using an Azure DevOps pipeline. And now Rune is going to show you a little bit about the Altinn Platform.
So the Altinn Platform is the part of our new platform that contains all the functionality needed by the apps. We have grouped the functionality into different containers or microservices, and those are available through APIs. The first component is the authentication component, and that's responsible for authenticating user and system wanting to accessing an app. The component works as an identity provider for the apps, and this again is integrated with other external identity provider like the national ID port in Norway. The authorization component is authorizing access for every apps, the APIs, and so on. And this is a SACML 3.0 policy decision point that reads the policy file defined as part of the application repository just mentioned by Nina. So every app will call the authorization point, and we will get a response saying if the user or system can access it or not. We believe that this component can be used in other type of scenario. It's available in our source code and could be used in everywhere else where you can use a PDP. Then you have the profile component where it gets the user information for the users. You have the register component where you find information about all the citizens and the businesses of Norway, often used in apps. We have the receipt component that provides a receipt for earlier communication with the government. And all those apps I mentioned now are based on ASP.NET Core. But the PDF component is in fact a Java application. And the reason for that is that we were not able to find a good enough open source PDF tool for .NET. So if anyone else will build it, we really truly appreciate it. So, and then we have the receipt component. The storage component, where you find the storage functionality for apps. This is where the user will end up storing their data. And this is also where the agency will retrieve their data through APIs. So when a user submits data in our app, the app will call this storage component and it will be stored down to a separate storage account in Azure. So those are the components we have. And the next step is what kind of cloud architecture are we building? And Stephanie is going to give you the details about that.
Thanks. That's it. So guys, we're going to move on to talk a bit about our public cloud components and our architecture in Azure. We're going to exemplify this by looking at how we deploy our microservices. And so Microsoft actually established the first Norwegian data centers this winter, one placed east and one placed west in the country. This makes them the only large cloud provider with data centers in Norway. Given that they have 2 data centers, we're able to have redundancy within Norwegian borders. And this is great as we then can take on application owners that have a requirement that their data be stored within Norway. Another great thing about using the Norwegian data centers is that we get a lower latency in the communications between our on-premise and cloud solutions. And so Nina and Rune have told you guys about our different microservices. So we have the different platform components, and we also have the apps of our users and Altinn Studio. What I want to take you through is how do we get from a bunch of code on GitHub or Gitty to running services online. The exciting thing here is that the concepts that I'm going to show you are the same we use whether we're deploying our microservices or the microservices of our users, the app developers. And so the first step, of course, is source control. We use GitHub for all the code that we're developing and Gitty for all the code related to the applications. At this stage, we also like to run analysis on our code. So we use LGTM, looks good to me, for security analysis, and Sonar Cloud to ensure that we have a maintainable code base. And that's just a few of the tools that we're using. And so once we have a new feature for the platform, or an application owner decides it's time to build their app, a build pipeline is triggered in Azure DevOps. And so this build pipeline is made out of ready template tasks in Azure DevOps, making them really easy to configure. It's a two-step pipeline where the first step is building a Docker image, and the second step is pushing that image to container registry. Container registry is hosted in Azure, and this is where we store all our images until we're ready to deploy the microservice. And there are two important things I'd like to point out about the container registry. The first point being that we are a public platform, and our users must be able to trust that their data is safe, going back to the isolation principle. This is why we have a container registry for each of our application owners, where only their Docker images are stored. Secondly, a single Docker image might be deployed to multiple environments, so both testing and production. This is why we treat our container registry and all the Docker images as production resources, meaning that we set restrictions on what and who is able to access the resource, as well as which availability we're expecting, and also which region we're hosting the resource in. So next step, once we have the Docker image in container registry and we're ready to deploy the microservice, is that we trigger a release pipeline. This is also hosted in Azure DevOps. And this pipeline would use Helm to install the microservice on the cluster. But I do have a confession to make before we'll take a closer look at the release pipeline. Because we are an open source project, and we really like mentioning it because we really like that fact. But truth be told, we do have an additional repository which is protected. And this is where we store sensitive data such as Helm charts and instrumentation keys for some of our resources in Azure. And so this Helm chart and the other secrets are packed as an artifact and included into the release pipeline that way. What we see here is an overview of the release pipeline for one of our platform components. We can see that two artifacts are included in the pipeline. The first artifact is to identify which Docker image we want to deploy, and the second artifact would be the Helm charts from that repository I was just mentioning. So once we have the artifacts, we're ready to deploy this microservice to one of our environments. And what we can see here are all of our environments listed up. So in the first stage, you'll find our acceptance testing and load testing environments. In the second stage, we have the testing environment for our application owners. And then finally, we have production. And so for these various stages, we have different triggers. With regards to a platform component, a new release would go to the acceptance testing environments whenever a new Docker container is available or a Docker image is available. For our application owner testing environments and also production, we have weekly releases. And we also have some manual checkpoints prior to each release to ensure that we have people at work in case something was to go wrong. But the most important thing about this release pipeline is the tasks that it completes. And the most important task is that the pipeline would run a Helm upgrade or Helm install task depending on if the microservice has been deployed previously or not. And the result of this task is that a new pod will spin up in the Azure Kubernetes services cluster. Which brings us to the final step. So a new pod spins up in the Kubernetes cluster, and the referenced Docker image is pulled onto the pod, and the microservice starts up. And it's always ensured that the microservice is fully up and running before we terminate any pre-existing versions of that microservice. And this results in a deploy without any downtime. And so this is our overall process for getting from code on GitHub to running services online. And again, it's the exact same process, whether we're deploying our microservices, so a platform component, or the applications of our users. But let's take a look at how this looks in Azure once all the microservices are deployed. So what we can see here is an overview of how we've set up our infrastructure in Azure for our different solutions. Starting with Altinn Studio, we can see that this runs in a separate Kubernetes cluster. And you can see the two services, Altinn Designer and Altinn Repositories. Within Altinn Studio, you'll also find the virtual network. We have a key vault where we store secrets and certificates that are accessible by the microservices. And we have an ingress route to control the traffic onto the correct node running the pods. And then we have a load balancer to direct the traffic to the right microservice again. And I think that's the other way around, sorry. So the load balancer handles the incoming network traffic, so directing us to the correct node, and then the ingress route would direct us to the correct microservice. We can also see the connection here to the build and deploy or build and release pipelines that are triggered by our users when they're building and deploying their applications through Altinn Studio. So the next component is Altinn Studio, and I think this might be the most exciting part of our infrastructure. So what we can see here are two examples of application clusters, and they've each got 4 running applications each. So when an application owner decides to join our solution, they're given 2 Azure subscriptions, one for their testing resources and one for their production resources. Within this subscription, you'll find the Kubernetes cluster where they host their microservices or their apps. You'll find the key vault for sensitive data, accessible by the microservices. You'll find the virtual network, the container registry where we store the Docker images, and you'll also find the storage account. In this storage account, we'll store all the data collected through their applications. And again, we have the ingress route to control the incoming network traffic and the load balancer. And common for these apps is that many of them would require the shared platform. And so the communication to get from the apps to the platform has to pass through an application gateway and then API management before reaching our microservices. And so what we can see listed here are our different services in the platform. Each platform component runs on their own Docker container. We do actually have quite a bit of communication within these microservices as well, especially to the authorization component to authorize the different actions. And so this communication is enabled through Linkerd, and we have an encrypted pod-to-pod communication. So this saves us from routing that traffic through the internet and then back to the same Kubernetes cluster. I'd like to draw your attention to the bottom component, platform storage. We can see that this component would connect to Cosmos DB or a storage account depending on who owns the data it's handling in a given transaction. We also have our connection to the on-premise environment, which is Altinn 2. And so this is enabled with an express route. And this gives us a high-speed communication between our on-prem and cloud solution. And so looking at this infrastructure as a whole, there's a varying level of how consistent the components are. For Altinn Apps, for instance, we'll be having new service owners or application owners wanting to join our solution, or we'll have requests to upgrade some of their components. And of course, we have the standard work like upgrading our Kubernetes services cluster or our version of application gateway, for instance. And we've struggled a bit with finding a good way to maintain our infrastructure. But recently, we started using Terraform. And Terraform is a great tool as it allows us both to provision and evolve our infrastructure. And even better, it's all written in code. That allows developers like us to take a much larger part in both setting up and maintaining our infrastructure. This is because we're able to read the code and modify it to suit our needs. And so looking at this picture, you can see that there are quite a number of cloud components involved in setting up our infrastructure. And of course, some parallels can be drawn to technology that we've used on-premise, but not always. And so when we've tried to select which cloud components to use, or how to configure our virtual network, for instance, we've had to base our decisions on the points that you can see here. And so I would say that the point right at the bottom here might be the most important one. So which components do we think have the potential to evolve along with our platform and the capabilities that we expect to deliver or offer in the future? And I think this says something about daring to imagine what the future looks like or dream about what we wish the future might be, even though we don't have it right now. And in some cases, it also means doing the necessary work to make sure that our needs and expectations are made clear onto those that are further developing Azure. And so here we can see the most central cloud components that we're using at the moment. And luckily, a lot of these components are fully managed by Azure. This limits the number of variables for us to tweak, as well as the time we need to spend maintaining these resources. And we would have never had the capacity to have this many new components in our solution all at once if we were supposed to manage them all ourselves. And my reason for emphasizing that these are the components that we're using at the moment is that we do have a quite high rate of change, I would say. So we started developing this solution before the Norwegian data centers were established. This means that we've had to adapt to which features would be offered in Norway and not. Also taking into account the rapid evolution of cloud technology, we're always prepared to swap out a component or to upgrade the existing ones that we have. And again, Terraform, as I mentioned, is a great tool for doing exactly that. Another important thing for us lately has been cost management with regards to these cloud components. Because if you're not shy when selecting a cost plan for these components, the bills could quickly add up. And so we've had to sit down and ask ourselves questions like, do we need the trace log from our backup function? And how long are we actually willing to wait to find log data that's more than 30 days old? And by asking these questions, we've been able to, sorry, lost the thread there. Let me just get back in. So asking these questions, we've been able to tweak our solution in order to save costs without compromising the functionality of our solution. And so I'm going to go on to talk a bit about some of the cloud components that we're really happy with using. The first one, of course, is Azure Kubernetes services. And so as you could see from our infrastructure, we do have quite a number of Kubernetes clusters. And again, this is a great resource because it's fully managed. This means that we have very few responsibilities outside of deploying our microservices and managing them. In addition, Azure Kubernetes Services supports auto-scaling. So this means that our applications are able to scale both up and down depending on the load that they're facing. Once we've transferred all of the application owners from Altinn 2 to Altinn 3, we're expecting to have several hundred Kubernetes clusters. And so Microsoft's Azure team might have a bit more to do, but we should be able to manage just fine. We have Azure Cosmos DB. So this is a document database that we use to store metadata about the applications and their instances. Cosmos DB is said to be highly available, and it's documented to have an availability of 99.999%. Pretty high. And if that wasn't enough, it also duplicates our data into multiple locations automatically. As this database is hosted in Azure, you could say that we have an unlimited amount of storage, should we need it. And at Microsoft Build, Autoscaling for Cosmos DB was announced, and we're really excited to incorporate this feature into our solution as well. Finally, we've saved the best for last, application insights. And so you know when you have a bug and you're not quite sure where the root cause is or where to start debugging, well, application insights would be my starting point 9 out of 10 times. And so we use application insights to monitor our microservices. So this goes for both the platform components, Altinn Studio, and also all the apps of our application owners. App Insights would draw out an application map, as you can see here, where we can see all of our microservices and also the communication lines between them. Another feature that Application Insights provides is that we can drill down to a specific time frame and see which requests are used the most often and also their average response times. Another great feature is drilling into a single request. And this way we can see how the request flows through all of our services. And these two features that I just mentioned have been heavily used during our load testing. We've been able to identify bottlenecks and unnecessary or duplicate requests as well. So I'm going to hand you guys over to Nina now, and she's going to share a bit about our experiences working on this project. Thank you.
So we've been working on this project now for a little over 2 years. And we are definitely some experiences richer, and we would like to share some of those experiences with you guys. So the first point that I would like to make is that working on an open source project has been really great. We have our backlog open on GitHub. On the right side here you can see a screenshot from just a few days ago. Having our backlog open on GitHub, in addition, of course, to our source code, means that we have gotten feedback and wishes from the app developers and government agencies that have been following this project at a very early stage. We've had app developers submit issues, and they can follow the progress of those issues to see how they will be solved. Now, since we also only use open source projects ourselves, we can do the same. So we can modify things to suit our needs. We also have a great insight into when new functionality will become available in the tools and frameworks that we use. Now, while having an open backlog on GitHub has been a really good thing, sort of plain GitHub as a tool for managing the project and managing the backlog has not worked that well for us. Currently, we are a quite small team, and that makes it manageable. But as you can see at the very top of this screenshot from our backlog, there are currently almost 600 open issues, and there have been a lot more. So actually managing this and prioritizing and seeing who is working on what has been quite challenging, especially previously when we were a much larger team. We've had to test several different plugins to work with GitHub, and we've ended up with a plugin called ZenHub, which we feel works quite well for us. Finally, a note on direction. And we would like to say that shifting direction mid-project can actually be a good thing. Now, to elaborate a little bit on that, when we started this project, we focused a lot around the Altinn Studio solution as a tool to build apps. We focused so much on the tool and possibly not enough on the actual apps themselves. Underways, we decided to switch our direction to focus more on on the actual apps. Now this resulted in us having to switch also from focusing on users who do not know coding towards users who actually do know how to code. And I'm sure you've seen this reflected in what we've been explaining today. Probably you would need to know at least a little bit of coding to properly customize your app. Hopefully, going forward, we can now continue building on the Altinn Studio solution now that our apps are more mature. All right. I'll hand you over to Rune, who will tell you a little bit more about our current status.
Yes, so it's now 6,000 days since Altinn 1 went into production. It's 3,500 days since Altinn 2 went into production. And there's over 2 years since we started these minimal viable products. So what is our status? Are we done yet? We went live on Monday, in fact. It's a great success for us that we are able to go launch this platform this Monday. So that means that the pilots are getting ready to deploy their first applications to the productions. So we are helping them out with the initial apps. We have around 600 open issues, as mentioned. And we are still working from home, but it works fine. And forward, we're going to focus on more stuff. Because, as I mentioned, we have more than 1,000 digital services on this old platform. And we want to move that to the new one. So we will focus on building more flexibility on the forms, being able to build more advanced forms, components, and so on. We will expand the types of process tasks we can support, like payment and signing, we will add, and many more. And this is an event-driven architecture, and we need to define how we're going to expose the events. So because the goal for us is that we want to have an event feed for every citizen of Norway, every organization, and every agency. And it's going to be an exciting task to build that solution. As mentioned many times, we are open source. Our documentation is fully open source that also. And on Github, you will find a link to the different documentation we have. And we will find a full detail about the requirements, both functional and technical requirements, the principles we have, the different patterns we follow, what kind of capabilities, both on the DevOps capabilities and the runtime capabilities of the platform, and all the components and code structure we are building. So every design details you find there. Go take a look. You can find details about all the platform components. So, and you will also find the presentation we just had on there on a couple of hours. And with that, I want to thank everyone for joining. We're going to thank NDC for letting us come and present. And we are opening up for answering questions from Slack.
Yeah, so I can see we have a few questions on YouTube, so we'll start here first. The first question is, are the development teams centered around those microservices? So do we have an authorization team and a PDF team, and etc.? And so are the different teams available? Let's see, are they responsible for the different services?
And I guess the answer now, no, not yet. We are currently not that big team, and we are covering more components, but there are special member of teams that focus on different components. So currently, we have one team sharing all components.
And to speak of that team, we're like 5 or 6 developers, so it's not that big a team. I don't even think we have enough team members to have a component each. So another question here, let's see. So you mentioned that you don't do multi-tenant architecture. Is this due to a government requirement?
We, of course, investigate what the government agency needs and so on. And some agency would require that they have an infrastructure that is separate from others. So, and we want to support as many agencies as possible. And it's based on history on current platform that is not separated. We have seen instances of poor code in one digital service affecting others because of a high load and so on. So it's a natural by experience and some requirement.
Yeah. And so another question from Brian here is, since you're running multiple, several hundred, soon to be several hundred, we're not quite there yet, but it's coming. So since we're running several Kubernetes clusters and application insights and Cosmos DB, how are we hosting the costs? Do you want to answer that, Nina?
I think Rune has the best answer for this.
Yeah, so currently this is a governmental platform and it will be that. So how the cost is shared is kind of a deal that is between the agency and the Norwegian Digitalization Agency. And I think with the new architecture, it is more possible to split the cost if they want it to the different agencies. Currently, on the current platform, that's impossible because we are using shared resources and kind of saying that you are using 10% and the Euro 7, it's not possible. Yeah.
And we've used the examples of application owners with really large attachments, for instance. Should we share those costs, or should they be responsible for paying for storing those attachments? And with their separate storage accounts, it's pretty easy to see, how much they're using and what it costs. So another good question here, let's see. Tom had the same questions as Brian, so let's hope we answer them. We have Cybernetics 100. So despite all the good work with the new Altinn platform, what are some top challenges that still remain to be addressed in or by the new platform? We're taking too long to think here.
Okay, well, one thing that I think was barely mentioned at the end was this idea of being able to build the services without actually having a lot of technical background. In the existing application or in the existing platform, we do, yes, there are flaws, but it is possible to build a complete digital service without actually having to know any code. I would say that if you're going to build an app in the Altinn 3 solution right now and you don't know anything about coding, it would have to be a very, very simple app. So extending that and making it easier to actually build the apps, that's probably something.
Yeah, we have seen during the development time that when making it user-friendly, it limits the flexibility. And I don't believe that we really want to go 100% usability, what we talked about, because I think it's easier. We are learning kids to code. We can learn the agencies to code also.
Pretty much, yeah. Let's see. And so Brian made a comment here regarding the costs. He's saying, oil money. Say no more. Yeah. I guess that might be true. We have another question here from Stefan. So could you say anything about the advantages that you gain from hosting in the cloud versus on-premise?
Do you want to take this one?
I could so I was talking about application insights, right? And I think, so we're using that only to react to instances or incidents at the moment. But using this as a predictive tool as well, I think would be great. And also for our agencies to get more feedback on how their applications are used and when they're used, to be able to collect more data about the citizens or the companies that they're interacting with. And I think another great thing would be to run larger analysis on the data sets that they're collecting, because that's pretty easy now that it's in the cloud. Do we have any other advantages?
Well, I think the last thing you mentioned that because having one common platform, in theory, you have enormous advantage doing big data analysis of the data going through. So for an agency, if they want to.
Yeah, and so a final question here. We have another one from Brian. So Azure DevOps, Azure API Management, Cosmos DB. Would we say that we're heavily cloud locked, or if we were to decide to go to a competing vendor or go back to an on-premise solution?
It's a good question, and one of the other principles I didn't mention was to prevent that we are locking ourselves in. We have selected like Cosmos DB, but it's a document database, and we could replace it with something else. API management probably will be more difficult, but we are not using so much of the features in API management. It's just a gateway for API, so we could easily, probably with some weeks of work, replace it with another software. So it has been an important requirement for the Norwegian digitalization that we're not locking in on this on Azure, because we are selecting Azure now, and it could be something else in the future. So, yeah, it's important for us too.
Yeah, we should get some more data centers in Norway then,
Yeah.
I would
Yeah.
say, before we could consider them. I think that's about what we have of time. Thanks so much for watching us, guys. Reach out to us on Twitter, LinkedIn, wherever.
And go see our code on
Yeah.
GitHub.
Yeah.
Yeah, link is
Try.
right here.
Make a pull request, please.
Thank you.